Before we begin, let me ask you something. When you look at your computer screen, as you most likely are doing right now, do you ever wonder how this all happens? You're watching a video created by me, someone who could live anywhere between 10 or thousands of miles away from you. You could be watching it right after it was uploaded, or decades in the future. And that's seriously pretty crazy. The fact that we can interact with anyone around the world at any time is one of the most powerful parts of our modern technology. But to someone who's just getting into programming, that can seem pretty scary. These giant, complex programs we see every day can frighten people, make them think that since they can't program something like that right now, they never will be able to, and that programming as a skill is just too hard to get into. Thankfully, though, the basics of programming, like most things, are a lot easier than many might think. Hey, I'm Jackson, and I'm a team member here at STEMY. And today, I want to guide you through an introduction to the basics of programming and try to make the kind of video I would have found helpful when I was just starting out. The good thing is, most of these topics are pretty easy and they stack on top of each other like building blocks. So the better your basic knowledge is, the easier it is to understand the things at the top. To start, we're going to look at what a program is made up of. You might already know this, but the answer is computer code. Now, this code is written in what is called a programming language, which is similar to what we speak, but changed a bit to make it easier for the computer to understand. There are hundreds of programming languages, each different in their own way, but the cool part of learning the basics that underpins programming is that it makes it easier to learn the languages as you need to. While I talk, I'm going to be showing examples on screen, and keep in mind that these examples are not written in a real programming languages. Instead, it'll be in pseudocode, which is an English-like language that is useful for planning out your code, but also helpful for showing beginners the concepts that I'll be talking about later. One thing to note though, is the code we write is not what the computer actually reads when it executes or runs the program we create. Instead, another program called a compiler will take our code and convert it into binary, which is the language made up of ones and zeros that's the only thing computers can understand and use. Usually though, you never have to worry about actually compiling the code yourself, as the most popular software for writing programs will do it for you. So we know what programs are created from, but now we need to know how to actually fill them with working code. The first step in that is understanding variables. Variables in computer science aren't actually that different from the variables you may have learned of in math, but instead of representing just numbers, they can store much more types of data. This includes data like characters, words, and even a special on and off state called Boolean. Variables are there so you don't have to keep typing out the same log, number, or sentence every time you need to use it in your program. Instead, you write the name of the variable and the computer will automatically use the data stored within. The most important feature of variables, though, is the fact that they can transport data around the program, allowing you to change data in one part and then store it to use somewhere else. This leads to our second important concept, control statements. Control statements do exactly what the name sounds like. They control how a program will execute through its lines of code. If programs stayed the same all the time, they actually wouldn't be able to do that much, as they would have to put all data through the same code that might not make sense for what is entered. Control statements allow the program to change what it does depending on what is entered. This is normally done through the use of if statements. An if statement has a confusingly named conditional statement, which decides if the computer should run the code that is in the body of the if statement. Variables can then be added to if statements, and depending on what's stored in the variable, the if statement can decide whether to execute the code in the body or not. For example, say a variable named x has the number 5 stored in it. Then, down in this if statement, the conditional statement looks to see if what's currently stored in x is equal to 3. Since 5 is stored in x and 5 does not equal 3, the condition is not met and we skip the code in the body of the if statement. However, if x has 3 stored in it and the condition is met, as 3 is equal to 3, and the program will run the code in the body, adding 1 to the value stored in x. Notice though, that no matter if the code in the body is run or not, it still moves on to the next line of code, which in this case is print, which will display what is stored in x on screen. So we know how to store and move data in our programs, and we know how to change what code is run and which is not. The last major tool for programming is what is known as recursion, which is a fancy word for code that repeats. The most basic way of doing this is through loops, such as a while loop. Like control statements, loops have a conditional statement, which determines if the code inside should be run or not. However, instead of only running the code once, loops will keep running whatever is in its body for however long the conditional statement is met. So, say a variable x has 2 stored within it, and a condition for this while loop says that as long as whatever is stored in x is less than 5, run whatever is in the body. The first time, since x is 2 and 2 is less than 5, we run the code in the body, which adds 1 to the value in x and stores that in x, therefore making x now contain 3. We then go back to the conditional statement where x, now 3, is still less than 5, so we run the body again, and x is now 4. 4 is still less than 5, so we do it one more time, making x equal to 5, which is not less than 5, therefore the condition is not met, and we move past the loop to the rest of the program. This ability to constantly repeat code and keep changing data until it is what we need it to be is a very powerful tool, but can also be a bit dangerous. If code is not properly written and a good conditional statement isn't set, what is called an infinite loop could be created. With an infinite loop, the program does not know when to stop the loop, as whatever condition has been set will never be met. If this happens, the loop will keep running forever, eventually crashing the program. This is obviously not great, and you should always make sure you're paying attention to and thinking ahead in the code you write to make sure you don't actually code problems like this into your programs. So that, by and large, is the true basics of programming. Every program is built on a combination of variables, control statements, and recursion, and while there are certainly more complicated forms and advanced techniques for each of these three topics, learning what they are and how they work together in program construction makes it much easier to build your way to those higher levels. There's still always more to learn though, especially in a constantly changing field like computer science, so look out for any future videos where I'll dive deeper into concepts that allow you to flesh out your programs. Also, make sure to check out the rest of STEMY's videos, which cover all sorts of topics regarding STEM. And with that, I'll see you next time.